Okay, hello everyone. Today we will be talking about the lesson we learned a while ago. So let's begin. So integrated Ray law. So originally we are given the Ray law, right? And now we are just trying to integrate it, and we get those corresponding integrated Ray law. And yeah. So there's a little bit of calculus that's being involved, and based on that information there, the integrated rate law, all those three different equations, they are straight lines. For example, like the first one, ln concentration of A with respect to T is having a linear relationship with the time. And the second order, the inverse of the concentration of A is having a straight line relationship with the time t. If we take a look at those three different graphs, the one that's being a straight line is going to be the order of the Ray law of the reaction. And this is the half-life. So the half-life is the time that required for a substance to reduce half of its amount. And also most of the time this time is being affected by the concentration of the reactants also. And those are the deriving of the formulas. And the only one that has nothing to do with the concentration is this one, the first order. It is straight up ln 2 over K. It is always constant. Yeah, let's take a look at this question. So a certain first order reaction has a half-life of 20 minutes. If we look back, we can see this formula over here, and the ln 2, and this is going to be the half-life, and this is going to be our constant equation. No, the Ray law constant K, this is. And how long does it take for 75% to be completed? You can just sub in into this formula, or you can use the exponential form, it doesn't matter. If you sub in, because you know the K, right? And you know that the half-life is going to make the new concentration to be half of its original. And we have the ln 2, right? No, sorry. This is 75%. My bad. So 75% complete. So you have the ln 0.75 divided by this number. You get the time of half-life. Then graphically determine of the order of the reaction. Yeah, line of regression. We are just using the best line of fit, and we just and just using the best line formula. There's nothing much to talk about this. And yeah, we got a very nasty equation here, and Miss Baller, she says she might test it in a separate, I don't know. And she said if you are interested, you can just take a look at this by yourself and maybe discuss with her, and maybe we can have like an extra test or something. And that's pretty much this unit, huh? Or maybe I can talk about the lab we did, huh? So this is the lab we did. So how does this go is that we are given two different solutions, namely A and B, and A has this iodine ion and B has this hydrogen bisulfite ion, and we will be mixing them, and we dilute one and keeping the other the same, and we will try to determine the effect of the concentration on how fast of the reaction is going. So the rate, how we determine that is if all of the hydrogen bisulfide ion is being used up, we will know that the reaction is complete, and we will time how long does it take for this black solid something, the color change take place. And those are the dilution and how much concentration we have. Okay, my bad. So we have two different pipette. So one pipette is used specifically for 10 milliliter. It is extremely accurate for that amount. However, it cannot have it cannot measure like anything that's beyond or below the volume. And the more pipette, the volumetric pipette, it has like all of the scales. We can see that how much is that injected, but the problem is it cannot be as exact as the more pipette for measuring 10 milliliter of the reactant. And stopwatch, we are just using our cell phone, okay? And yeah. Yeah, and how does this go is we will first get two different beakers, and then we will be using and we just pour the two solution into our beaker. And for the first 5 trials, we first put the diluted version of volume A into a test tube rack, and then we will be using a pipette to inject the solution B. And one person is injecting, one person is timing, and one person is kind of doing nothing. And for the 6 to 9, you are just reversing B and A. Now you are preparing B first and injecting A. Yeah, so that's how does our lab requirement looks like. Yeah, according to our result, we get it is approximately first order with respect to iodine ion and the second order with respect to hydrogen bisulfite. I don't know if this is correct or not, but that's the experimental rate law we obtained. And yeah, I guess this is the video for today. Thank you everybody for watching, and see you in the next one.